Hi, it's Mr. Anderson, and in this video I'm going to talk about standard deviation. When you're collecting data in a science lab, the amount of data you collect is important. So is the average. But another important statistic is going to be the standard deviation of your sample. And so in this video I'm going to show you what it is conceptually. I'm then going to show you how to calculate standard deviation by hand, and then finally I'm going to show you how to calculate it using a spreadsheet. And so first of all, what is it? Well, to understand standard deviation, you have to understand the normal distribution. And so what does that mean? Well, it's a bell-shaped curve. You might think of it like that. And so in the United States, most men are about 5'9". In other words, that's the average right here. That's the mean, or in statistics, that's the X bar. But there's going to be a lot of men who obviously are taller than that, and a lot who are shorter than that. And so the standard deviation is going to measure the spread or the variation in this bell-shaped curve. And so basically, if we were to go right over to here, this dark area is going to be one standard deviation above and one standard deviation below the mean, or it's going to be below the average. And there's something cool about that. About 68% of the individuals are going to be in this area. So one standard deviation above and below. If we were to look at this, for example, down here is two standard deviations. And so 95% of individuals are going to be within two standard deviations from that mean. And then finally, if we go way down here, 99% of individuals are going to be within three standard deviations of the mean. But the standard deviation is going to vary depending on the data that you collect. And so if we had two curves like this, so if this is one curve, and then we had another curve that looked like this, that data plotted on the same curve, this one is going to have a smaller standard deviation than this one. They're both going to have standard deviations, obviously. They're going to have amounts where it's 68, 95, and 99% of the people. But this one down here, since it's more spread out, is going to have a higher standard deviation. And so how do we calculate that? Well, the equation is a little scary. The scary part, it ends up being right here. So students are a little scared by that, the summation symbol. But it's actually pretty straightforward. It's not that hard to calculate the standard deviation. And so let me show you how to do that. And so first thing you want to do is you want to have a data set. So here's going to be our data set right here. And to make this easy, let's say we just have 4 pieces of data, 1, 2, 3, 4, and 5. So you're collecting data, and this is the data in your data table. And you want to figure out the standard deviation of that. Well, to set that up, we're basically going to take the square root of the summation of this divided by the degrees of freedom. So that sounds a little bit scary. And so let's go to the scariest part to begin with. So let's look at what's going on right here underneath that square root. And so what this is, so if we go like this, the summation of x minus x bar squared basically means for each of these data points that I have, we're going to have to figure out what's right here. So x minus x bar. And so the first thing we have to do is figure out what the average is. We have to figure out what x bar is. Well, basically, if I add 1, 2, 3, 4, 5 together, I get 15. And if I divide that by n, which is the total number of data points, so in this case, n equals 5. So we have 5 data points over here. So if I divide 15 by 5, hopefully you can figure out an average. The average is going to be 3. And so the mean is 3, or the average is 3. So what we have to do is we have to calculate this value for all 5 of these data points. What does that mean? Well, right here we're going to use x, and x for the first case is going to be 1. So that's going to be 1 minus 3, and then we're going to square that. So what is that? 1 minus 3, and we square that, is going to be negative 2. And if we square that, so that's negative 2 squared. And if we square that, that's 4. Let's go to the next one. Well, this is 2 minus 3, so that stays the same. So that's negative 1 squared. And so that's going to be negative 1 squared, or that's going to equal 1. If we go to the next one, that's easy. That's 3 minus 3 squared equals 0. And if we square 0, that's going to be 0. Go to the next one. That's going to be 4 minus 3. And so that's going to be 1 squared, or equal to 1. And then finally, if we go 5 minus 3, square it, that's going to be 2 squared, and that's going to equal 4. And so if you ever see the summation sign, don't be scared by that. It's not scary at all. It just means you got to do a lot of work. So for each of these data points, 1 through 5, I had to calculate what was in there. And then I have to add it all up. So I have to add 4 plus 1 plus 1 plus 4, and if I add all those up, I get 10. And so what's going to be inside there? It's simply going to be 10. So let's figure out the rest of my standard deviation. Standard deviation is going to be the square root. In this case, we solve this as equal to 10, and then we're going to divide that by n minus 1. So what's n? That's our sample size. In this case, it's 5, and so we take n minus 1, and that's going to equal 4. And so what is our standard deviation? It's the square root of 10 divided by 4, which is 2.5. Or if we take the standard deviation of the square root of 2.5, that's going to be something like 1.58. And so you're going to have to use a calculator to figure that out. Well, what does that mean? If we were to plot this data as a histogram, for example, this would be our standard deviation, 1.58. And so it takes a while to figure that out based on doing it by hand. And so if you want to, give it a try. And so here's data set over here. And so try to calculate the standard deviation using this data set over here and try to do it by hand. I'll put the answer down in the description below the video, but I would give it a try. It's worth doing once on your own. And again, this is going to be our formula, standard deviation. And so try to do that. Try to do that by hand. And so I'll wait. No, I won't wait for you to do that. Pause the video, try to do this one, and I'm going to show you how to calculate this really, really quickly. And so I'm going to show you the spreadsheet shortcut. And so how do you do that in a spreadsheet? It's pretty simple. So what I'm going to do is going to take this data, and I'm going to switch over here to Excel. So here's the data right here, 0, 2, 4, 5, and 7. And so I've entered my data into different cells, and now I'm going to figure out the mean, just to show you how easy this is. To figure out the mean, I'm going to hit it equals here, and then I'm just going to start typing. So I'm going to type in average, because the spreadsheet's not going to use the word mean. So I type in average, and then I select my data. I hit a close parentheses, I hit end, and it's going to give me my average, which is going to be 3.6. So if I wanted to know the average, there it is. If I wanted to know the median, for example, I could just type median, and I could go down like that. And so spreadsheets are super simple. And so what are we looking for? We're looking for the standard deviation. So how do I do that? I just hit equals. I then start typing STDEV. Can you see how it pops up right here? Standard deviation. Parentheses, then I'm going to select that. And then I'm going to go like that. So what's the standard deviation? It's 2.7. What does that mean? We had a bigger spread in the second data set than we did in the first set, a higher standard deviation. And if you did it by hand, it should have looked something like that. So that's standard deviation, and I hope that's helpful.